Hello everyone, this is Imtiaz Alam. Today I'll be presenting on serverless microservices patterns. And even though like my icons and diagram shows AWS, but you can use with any different cloud provider. So I've created a mapping table in each of these slides. Okay, so we're going to start from something very simple. And the first API we're going to look at is called internal API pattern. And you will use this pattern when you are like everything is in the same AWS internal infrastructure, and you're not going to expose these Lambda or these services to the outside world. So for some internal call or internal consumptions. So this is very plain simple. You have a Lambda, and basically you're calling a DynamoDB, or depending on the situation, you could use Cosmos, Oracle, whatever database choices works for you. The second pattern is the internal handoff pattern, and this one is basically useful for like processing events, right? So for example, when the client is calling your Lambda, you are basically processing those events, and let's say the the request that you got has some errors, maybe it's failing a business logic validations, or you are unable to process for some reason, you can redirect those to SQS DLQ for later processing. Another pattern we'll see is like a simple web service pattern. This is this pattern is basically just talking about you have a Lambda, you have API gateway, the request from the client goes to the gateway, and gateway redirects the call to the Lambda, and Lambda fetches the information from the database and returns it to the caller. Very simple. In this one, we do not have any authentication or authorization. Next thing we're going to see another pattern is kind of called a gatekeeper pattern. In this case, uh, assume that client is making a call. The API gateway calls the Lambda authorizer and basically tries to get the IAM policy. And once the API gateway has the IAM policy, it will call, it will verify the policy. If the policy is correct, that means if the customer is allowed to make a call, it will go through. Otherwise, the call will be rejected. So this is basically a policy-based call. This one is scalable webhook, and a scalable webhook uh, works better. For example, let's say you have unpredictable workload. You cannot predict how many calls you will get, right? So one of the advantage of using the Lambda or functions, cloud function, is basically it can auto scale. So you do not have to worry about uh, creating a new container and deploying the new services in the container. So the Lambda can automatically grow, right? So let's say you are getting the load that you cannot process, maybe it's too much. So you can just put into SQS all these requests, and then you have another Lambda that basically processing those requests as you can throttle it because you don't want your other system to slow down. So you could be like having some kind of a rate limit on the Lambda to process only the amount you want to process in a particular moment of time. And again, for anything that doesn't work or there's any issues, it can always go to SQS DLQ for further processing. The next pattern we'll look at is the aggregator pattern. And as you can see in the aggregator pattern, what you do is imagine like you're calling order history, Lambda, or anything that requires call to the multiple services. So instead of client making 3 calls or 20 calls to API gateway, client makes one call, and this Lambda basically calls multiple services or maybe database, whatever, collects all the information, aggregates it, and returns it to the caller. Next one is continuous stream pattern. This one is pattern is very important. It is useful for click stream or IoT data or sensor data, like you're getting huge continuous stream 24 by 7, right? So in that case, what you can do is all the requests coming to API gateway goes to Kinesis, and you can have a configurable sharding. You can decide how you want to shard your data. So these data goes to the Kinesis stream, And from there, it will go to the fire hose, and all the aggregation happens here at the fire hose level. And then finally, the data gets aggregated to S3 bucket. From here, it can be consumed by different services, or maybe if you have a need, you can just push everything to bulk load to Redshift. The next one is a state machine. This is kind of you can think about, you have a scenario where you want to move from one step to another step. For example, let's say you want a very good example is a vending machine scenario where you put up money. The step one, you make a choice, and step two, you press a button, step three, right? So thing has to go in a particular order. In that case, you could have like a lambda, and you can use a step functions. And once you do file your query, the step functions automatically take over one after another. The only disadvantage of having a step function is kind of a very pricey, because as you're moving from step one to step two to step three, every step will cost you additional money. So you need to see whether this is a right patterns for you. The next one is like a router pattern. So again, client makes a call to the Lambda, basically decides which type of task to execute based on the request, and basically it calls the other Lambda to do the request. Basically, so you have a main Lambda, right? This Lambda getting all the requests, and this Lambda is making a decision which type of task to execute. A robust API pattern. This one is basically where you're getting a lot of response and request. And this robust API pattern basically is kind of doing multiple things. Getting data from microservices, doing a DynamoDB, calling another services, and collecting everything and just returning the result as a part of a response. The third one is like a read heavy reporting engine. This is meant that if you have a like a read only, maybe a reporting system, so where you want a client to fetch the report. In that case, what you could do is from client you go to from the gateway, go to the Lambda. Lambda always query the elastic cache first. If the report is available in the cache, it returns. Otherwise, it will go to your RDS, SQL, or database, or whatever database you have, and fetch the result and store in the elastic cache, and then basically return from the result, right? So if for the read heavy thing, when the data is not changing a lot, I think it makes a lot of sense to put a caching layer, um, so that you don't have to go to database for every single request. This one is like a fan out, fan in. So again, it's very similar to the other like a router pattern kind of thing. But in this case, in this case, the request comes in and it gets distributed to multiple Lambda worker. Each worker does the work and kind of push the data into DynamoDB or S3 uh, bucket as per your requirement. This one is eventually consistent, is a very commonly used pattern in the distributed system. So it is basically used when we are not looking for an ACID compliant and transactional kind of a response, request from the client. So in this case, let's say client made some update. The update goes to, let's say, a DynamoDB, and then DynamoDB update is done and client is happy. Eventually, what will happen is these all events will going to get published to the stream, and then you have a Lambda that process those and basically distributes further to another RDS. But in this case, you can think of basically from the DynamoDB stream, and this Lambda is going to maybe updating the another instance of DynamoDB or pushing it to another region. It depends what you want to do. But the whole idea of this pattern is whatever you're going to make an update, eventually it will going to go and get updated in the entire system. Circuit breaker pattern, I think in this pattern basically is very useful. So basically what happens is when you make when the request comes to the your microservice, and let's say you're dependent on some third party call, right? So what happens is, by default we assume that the connection is closed. Closed means you are able to make a request. So let's make an assumption that you made a call to a third party and it's not available. So you can have like a failure count, And when the failure reaches to a certain threshold, right, then what you can do is you can just stop calling the third party again, but you will have a timeout. After a certain timeout, this pattern, what it will do is make certain amount of call, maybe 2% of the call will go to third party to see if it is available. So if you get the response back for those 2% request, then you kind of start sending the remaining of the request, like all the new request. But let's say if you made a call and you still failed, then you again will increase the timeout and you will stop calling for maybe another 30 seconds or another 1 minute. So it depends on how you configured. As the number of retry you're doing, you can increase the timeout duration. So basically wait duration before making a call. So there are three things to see. If the circuit is closed, that means you are able to make a call. If the circuit is open, that means there is no connection. So you're not making any call. You're just getting the status from maybe a cache. And half open scenarios when you are making a few requests to see if your API is still available. Okay, if it is available, then you basically close the connection and you send remaining of the request. This one pattern I did not put in my slide on LinkedIn, so I just added here. So this basically strangler pattern. This is very useful pattern when you are migrating from a monolith to microservices, or you have like a two different system and you want to call. So, but mostly strangler pattern is meant for the like when you're doing a migration from the legacy to the modern services. So in that case, your API gateway, you can decide that certain percentage of request will go to your legacy application, and all the like a new certain percentage will go to your newer application. And over the period of time, the number of requests going to a legacy application will go down to zero, and all 100% requests will go to your new service. Okay, and these are a couple references you can look at. I took a lot of help from all of these links, and here I end. Okay, thank you very much for watching. Please let me know your comment and feedback if I can improve it in any way. Thanks. Bye.